Hey guys, so today I'm going to be talking about a very specific type of uniform circular motion, which is the coin funnel, which is this really cool, just kind of looks like this, nice little 3D funnel drawing, and when you put a coin in it, and like you throw the coin in on its side, it travels around and around all the way down, going around the edges, which people really like watching because it kind of is contrary to what you think would happen, which would just be that it would fall down. So today I'm going to be explaining the physics of that. So as we do with any good physics problem, any good dynamics problem, we start with our free body diagram. So I'm going to take just like a nice little cross section of this picture, and you're going to see that it looks a lot like a normal ramp problem. I'm going to draw the little coin, and we're going to make the free body diagram. So first, we're going to draw the forces that we know are there. So the first force, I'm going to draw the weight force, which is always there, mg down. And then there's going to be a normal force. So I'm going to say Fn, and it's going to go directly out from the surface. So those are the two forces I'm going to make for now. There's going to be another one, but I'm going to explain why it's there, how we know that it's there. So first, I'm going to break these. So I'm going to try to prove why there's a net force into the center, because this, this is the funnel. In here is center. And right now, it's pretty unclear. It's like, where is that coming from? So what I'm going to do is break these forces down to their component parts, starting with the weight force. So I'm going to draw them as dotted lines, because they're not real forces. They're components, and this one's going to be mg sine theta, and this one's going to be mg cosine theta. Then I'm going to break the normal force down. So this one is going to be Fn sine theta, and this one's going to be Fn cosine theta. So right now we look at the free body diagram, and not all the forces seem to be balanced out. So what I'm going to do is now we see that we need something to balance out this mg sine theta down so that it doesn't move down, because it's at any given moment. So even though over time it moves down, at any given moment in uniform circular motion, just in like this one plane, and in theory it would go around in circles forever. So we actually can know that, and we know this anyway because it's on this surface on Earth, but we know there has to be a friction force here. And this friction force has to be equal to this mg sine theta. And since we know the formula friction force equals mu Fn, it's actually the absolute values, we know that in order for this to fully balance out this one, the normal force actually has to be greater than just what it usually is, which is just equal to mg cosine theta. So this is actually going to have more. Imagine that goes some off the page. And this would make this longer. So now you look at this free body diagram, and it's pretty easy to see that when you're looking in the x direction, this is x and this is y, the only force in the x direction, these balance out, all of these, the only force, and so therefore the net force, is this force towards center, which is how we know that it's in uniform circular motion. Now as to why in real life it does actually go down the ramp too. So since we are in the real world, not an ideal physics world, it eventually, these forces don't line up perfectly, and it will slip a little bit as it's going around. But as it goes down, people notice that it goes faster, and that seems counterintuitive. You'd think it would just keep going at the same speed. Why is it doing that? And that's actually because as it goes down in our gravitational field lines on Earth as well. So up here at the very top, it starts going around, it has a lot of potential energy and a little bit less kinetic energy. But then as it goes down the gravitational field lines, some of that potential energy becomes kinetic energy, and that just continues as it goes down. It just gets faster and faster and faster and faster, and then it goes until it goes all the way down. So yeah, that's how coin funnels work. I hope that made sense. Thank you for watching.